Last section in Unit 10, Section 10.9, polar equations for conics. We've talked about conics. We're coming up with slightly different equations, or at least slightly different definitions for this. We're kind of trimming a little bit off of this. We're not going to do all of 10.9. We're just focusing on one particular part. So, an alternative definition for conics. So, the locus of a point in the plane that moves so that its distance from a fixed point, that focus we've talked about, is a constant ratio to its distance from the fixed line, a directrix, is a conic. This constant ratio is the eccentricity of the conic and is denoted by the letter E. Moreover, the conic is an ellipse if E is less than 1, it's a parabola if E is equal to 1, and a hyperbola if E is greater than 1. Here is what that means more specifically. So we've got an ellipse, we've got a parabola, we've got a hyperbola. So in an ellipse, we're talking about a ratio from a point to the focus and a point to the directrix. So I'm just going to arbitrarily assign numbers here. So let's give this a distance of 3 and this a distance of 5. So the distance from the point to the focus divided by the distance from the point to the directrix, so point to focus, point to directrix, is less than 1. So essentially, if the line that is inside of the ellipse is smaller, or the line inside of the ellipse going from a point to a focus is going to be always shorter than that segment from that same point to the directrix. Now, for a parabola, one of the definitions we use is actually pretty much the same thing for this. If this is a distance of 3, this is a distance of 3. The distance between the point and the focus and the distance between that point and the directrix is going to be equal. So 1 divided by the other is always going to be equal to 1. So the parabola E is always equal to 1. Now, last one for hyperbola. The E value is going to be greater than 1. So the point to the focus is going to be larger than the point to the directrix. So like on this point to this focus, maybe that's like 7, and this is 4. The point to the focus is always going to be larger than the point to the directrix. So the point to the focus divided by the point to the directrix is going to be greater than 1. So with that in mind, we've got a couple equations, and we're going to use these to identify whether the equation is giving us or what type of conic it's going to give us, whether it's going to be ellipse, a parabola, or a hyperbola. So the graph of a polar equation, or the graph of a conic in a, goodness gracious, let me start that sentence over. The graph of a polar equation of these forms are conics. Now we've got r equals e times p, that same e value we just talked about, times p, over 1 plus or minus e times the cosine of theta, or r equals e times p over 1 plus or minus e times the sine of theta, is a conic. E's got to be greater than 1, and p is the distance from the focus to the directrix. So really the big thing we got to pay attention to here is the e part. Sorry, I'm in the copy room. You might have heard just the copy going. So we really just got to make these equations down at the bottom look similar to that. So looking at this first one, we have 32 over 3 plus 5 times the sine. So it kind of looks like this second equation here. Well, you notice the big thing is like, well, we don't really know what EP is. We have a 1 here, and we have a 3 here. So what we got to do is divide everything by 3. So we're going to divide the whole numerator by 3 and the whole denominator by 3. Now, dividing the whole numerator by 3, 32 divided by 3 is going to be 10 and 2/3. In the denominator, we're dividing both of those by 3. Let me zoom in a little bit. Sorry. We'll divide both of those by 3. We get 1 plus 5 over 3 times the sine of theta. Now, there's not a whole lot more we need to do here. The biggest thing we're looking for here is this e value. So we're going to say e is that number that's being multiplied by sine. So e is 5 over 3. Now, 5 over 3 is greater than 1. We're really just comparing these to 1 a lot. So like going back up here, if our e value is greater than 1, that means we have a hyperbola. Now, I'd like you to pause the video and try out these other two on your own, and come back when you're done. Okay, clearly you've tried them on your own. The second one here, not a whole lot we need to change because we already have 1 plus sine. Now, there's no e value listed there, but if there's nothing listed there, it's a 1. So e is equal to 1. And therefore, the 3 dots, it's a parabola. Letter C is pretty similar in nature to what we did for number 1. We got to make that a 1, so let's divide everything by 3 on top and on bottom. So we're just kind of scaling it down. So our numerator is now going to be 9 divided by 3. That's 3. Denominator 3 divided by 3 is 1. 2 divided by 3, so we got 2/3 times the cosine. So now we have that E value. E is equal to 2/3, which is less than 1. And since E is less than 1, going back up to our 3 options, E is less than 1 makes it an ellipse. And that is all.